Hello everyone, welcome to the video for the final year project on emotion detection from speech on a mobile phone. The project is made out of three parts as shown in the diagram. First, we have the Android mobile application, the front end of the entire project. Next, we have the deep learning neural network model, which is trained with publicly available speech emotion recognition dataset and is used to perform the prediction of emotion from speech. Lastly, we have the server, which handles and processes the audio file recorded by the mobile application and acts as the middleman between the Android application and the neural network model. To train the deep learning model, the project experimented with various augmentation methods. In this video, I'll be sharing two of them. The first is the removal of silence in the audio file, as silence do not carry emotion and hence should not be analyzed. The second is windowing, where each audio file are split into smaller segments with overlap between any two frames. Analysis of emotion is then performed on the smaller segments. This is done due to unsustainability of emotion existence throughout the entire duration of the audio file, and also to handle cases where an audio file has mixed emotions, such as being happy and sad at the same time. Aside from augmentations, the project also performed various experiments to boost the accuracy of the model. For this video, I'll be sharing two of them. Instead of training only one model that will be used for prediction, we have decided to train gender-independent model. One male model trained with only male voices, and a female model trained with only female voices. The first experiment we done is the use of a two-step classification method, where we first perform a binary classification of gender on the audio file to determine which gender the audio file belongs to. Next, now that we have known the gender, the audio file is then fed into the model of that particular gender predicted previously. This is done with the hope of achieving a better result, as the audio is predicted using a model trained specifically for that gender. Next, to ensure that the model trained is generalized to an independent dataset, we have decided to isolate one male and one female speaker from the EmoDB dataset to be used as the validation set. By doing this, the validation test would be performed on audio files of speaker which the model has not been exposed to, hence training a more robust model. The mobile application is designed with simplicity and user-friendliness in mind. The first screen a user would see when the application is launched would be the detection screen shown. This screen is designed to be intuitive, with only one button shown centered in the middle of the entire screen. With only one button and a helper text tapped to start detecting, it enables users to know clearly that upon clicking the button, the detection process will be started. Upon tapping on the button to start recording, a ripple effect circulating the button will be shown. This effect is added to ensure that sufficient feedback is given to user, informing them that the application is now recording the audio to be analyzed. In addition to the visual feedback, haptic feedback of a short vibration is added at both the start and end of the recording process. To cancel the detection process, user can simply tap back on the same button, which is now replaced with a cross sign. To submit the recording for analysis, user can click on the done button located at the bottom. The recording will automatically be submitted once 10 seconds has elapsed. Once the analysis is processed by the server and the result is communicated back to the mobile application, the predicted emotion will be displayed in the model form at the bottom of the screen. What's shown in the model is an animation of the predicted emotion along with a breakdown of the percentages of each emotion. With the tab design, user can choose to either click on the History tab or to slide their fingers across the screen to access the History screen. In this tab, the past history of detection and the respective emotion predicted and the breakdown will be shown.